Welcome to class today, pre-calculus students, on this Wednesday the 13th. I hope you guys are doing well today. Hope you're ready to learn some math. If there's any problems, questions, concerns, you have my phone number and you have my email, so be sure and contact me. Here are some quick announcements for your pleasure and enjoyment. There will be a quiz over the weekend. I will email that to you, Friday night or Saturday morning. Please stay on top of your integrity sheets, do the video, do the homework, and then write it down. When you put it off, that just makes it a lot harder to keep track of. Remember, when you come to my house on that Monday in a couple weeks, when you walk in the door, you're not allowed to watch any more videos or do homework and get credit for it. And you've got to hand me a hard copy sheet of paper with your work done. And then all of your tests are due by today. I've not heard from anyone yet. I might try to send out an email reminder, but your tests are due today. Okay, so points will be taken off if that's not done. Okay, all right, let's go ahead and get started. Grab your notebooks, pens, pencils, calculator books, and let's get started. Students, we're going to look at a topic today called multiplying and dividing complex numbers in trig form. Please write that down. Multiplying and dividing complex numbers in trig form. Now, you're going to see tomorrow why this is really a helpful process. Using complex numbers when they're in trig form, because it can really be helpful and really save you time. You won't see that today, but you will see that tomorrow. Today's date's the 14th, so please copy that down. And you know my philosophy. I'm going to go pretty fast, so here I go, and pause the video or rewind it if you need to, okay? You already know how to multiply complex numbers that are in standard form. Let me show you how to multiply complex numbers that are in trig form. I think I was a little redundant here. Yeah. Now, first of all, don't write this down. Just watch, please. You don't need to write that. I mean, if you want to take notes, you can, but you don't need to. Let me very quickly remind you that we learned in Algebra 2 how to multiply complex numbers in standard form. Here's a complex number and a complex number in standard form. If I were to multiply these together, I would take 2 times 5 and 2 times I. So 2 times 5 is 10, and 2 times I is 2I. Then you would take this negative 3i and multiply it through. Negative 3i times 5 would be negative 15i. And negative 3i times positive I would be negative 3i squared. And then what you learned last year is everywhere there's an I squared, you're allowed to put negative 1. So where the I squared is, I'm going to put negative 1. And we know that because the square root of negative 1 equals I. We square both sides, so negative 1 equals I squared. Everything I'm saying, especially for you two new young men, that I did not have for Algebra 2. If you're not understanding this, don't worry about it. You don't have to know this right now. Later on this year, we're going to go over this, but I'm just trying to show you, in the past, you should have already known how to multiply complex numbers that are in standard form. Now, we have 10 plus 2i minus 15i plus 3. Negative times a negative. And then combine your like terms, and you'll get 13 minus 13i. 10 plus 3 gives you 13, and combine these two here and you get negative 13. So we know how to do that, okay? That's called multiplying complex numbers that are in standard form. However, today we're going to learn how to multiply complex numbers that are in trig form. And you know what? You're going to find it amazingly easy. Let me put a dot right here. So let's get after it. Go ahead and copy this problem down. And again, if you have to pause the video, pause. I'm going to keep moving. Copy this problem down, and let's learn how to multiply this complex number times this complex number, and notice they're both written in trig form. It's really easy. First of all, you take your outside numbers, which are the lengths of your hypotenuses, if there is such a word, and you're going to multiply them together. So square root of 2 times 2 is simply 2 square root of 2. That's so easy. That is amazingly easy. And then you simply add your angles. So here you have 45 degrees, here you have 330. Add them together, and you would have the cosine of 375 degrees. Plus I sine, and then add your two angles, and you'll get 375 degrees again if you add this angle and this angle. Now, the only problem with this answer, there is one thing I'd like you to do. Anytime that you get bigger than 360, like 375, I want you to write the smaller angle. For example, 375 means you went around 360 degrees and then 15 more degrees. So I would rather have you put 15 degrees here In fact, I'm going to take the word rather. I'm going to mandate that you put angles in here that are less than 360. So I want you to put 15 degrees. That's it, guys. That's it. You multiply these outside numbers times each other, and you write it right here, and then you add your angles. It just doesn't get any easier than that, okay? Now, are you saying to me, Mr. Earhart, that if I were to multiply, if I had this number here written in standard form and this number here written in standard form, and I did all the work that you did back here, that's the exact same thing as doing this right here? Yes, it is. It's identical. It is identical. Okay, so it's really cool how fast this is when it's in trig form. I think that's a lot faster than doing what we did back here when two numbers are in standard form. Okay, now let's try one more. Hopefully you're okay with this. Multiply the outside numbers, add the angles, and then make sure your angles are not bigger than 360. Let's try one more. Copy this down. Notice here what I've done for you is I've given you your problem in standard form. So the first thing we're going to do is we're going to convert these to trig form. All right, so let's do it really quickly. It shouldn't take long. And I thought I had my calculator with me here somewhere. I'm looking for it. Yeah, here it is. Okay, very good. All right, now let's very quickly convert this first number here to trig form. Now you say, Mr. Earhart, could we not just do our multiplication like this and this and this? Yeah, you could, but I don't want you to. I want you to practice using trig form. So let's take this number here, right here, this complex number, and let's convert it over to trig form. So very quickly, I'm going to take this number right here and let's write it in trig form. Notice I have positive square root of 3. That's somewhere around here. And then negative 1i, or negative 1. So I'm going to put my point approximately here. That's close enough. It really doesn't matter. And I'm going to draw my right triangle. Now, it doesn't matter if my point's perfect as long as my lengths here are perfect. For example, I'm going to label this side square root of 3, and I'm going to label this side 1 because I went down 1. There we go. So now I can very quickly find the hypotenuse by squaring my square root of 3 plus, and then squaring my 1. And I will get, let's see, when you square a square root, you get the number on the inside. When you square the 1, you get a 1. 3 plus 1 is 4, so square root of 4. So the hypotenuse is 2. So there's my hypotenuse. Pretty simple. Now I'm going to find this little angle right here called x. Okay? So I'm going to say tangent of x equals opposite over hypotenuse. So 1/2. So tangent of x, actually that's wrong and I apologize to you, it's opposite over adjacent, and I know that and that's my fault. So tangent of x is opposite over adjacent, 1 over square root of 3, and of course 1 over square root of 3, we know this by now, is the same thing as square root of 3 over 3. Now if you were to look on your table, you should find that is on your table, and the tangent of 30 degrees gives you square root of 3 over 3. So right here for this x, I'm going to put 30 degrees. And then remember, remember you always start here on the x-axis, you rotate all the way around to the hypotenuse, so the angle you want is 330 degrees. So there we go. I have written it in trig form, and the answer would be the length of the hypotenuse, which is 2, and then cosine of 330 plus I sine 330. So there we go. We just copied, or excuse me, we just found, I didn't want to do that, we just totally found this first trig number in trig, or this first complex number in trig form. And now let's find the trig form of the other number. All right, let's very quickly write this number here in trig form. So I've got a 1 and a positive 1, so I go over 1, over 1 and up 1, positive 1, positive 1. Draw my triangle straight down. This has a length of 1, this has a length of 1. If you were to use Pythagorean's theorem and find this hypotenuse, trust me, you'll get square root of 2. I'm going a little faster, but we know how to do that on our own. So there's the hypotenuse, and now we're going to find this angle here. So we're saying the tangent of x equals opposite over adjacent. And that also should be on your list. on your chart, and you'll see the tangent of 45 degrees gives you 1. So I know this little angle here is 45 degrees. Now if I start here on the x-axis and rotate to the hypotenuse, I get 45 degrees. So it looks like to me, if I were to write this number in trig form, the hypotenuse is square root of 2, and then over here I'm going to have, let's see, the cosine of, and what did I say it was, 45 degrees. So the cosine of 45 degrees plus I sine of 45 degrees. And then we go ahead and do our multiplication. Now I did know that this was going to be the exact same problem, but I wanted you to see that you can first take this right here and convert it over to trig form and then do the multiplication. And now, of course, this ends up being, if you'll look, this ends up being the exact same problem we have over here, which is fine. So we already know we're going to get 2 times square root of 2 is 2 square root of 2. And then when you add your angles together, you'll get 375. So instead of putting 375, we're going to put this and this. All right? 15 degrees. Now, one reason I wanted to do this is I wanted to very quickly show you that if I were to take these two and quickly multiply them out, square root of 3 times 1 is square root of 3, square root of 3 times I is square root of 3I, and then negative I times 1 is negative 1I, and then negative I times I is negative I squared. But don't forget, for I squared we can put a negative 1, so you really have a negative 1 here, and then a negative times a negative is a positive 1. If you were to type this into your calculator and get decimals and then combine like terms and write it in standard form and then do the same thing down here, take cosine of 15, get a decimal, I sine of 15, get a decimal, and then multiply each of those by 2 square root of 2 and get out decimals, these two answers would match identically. Now if you want to play around with that and try and see, you can do that. I'm going to save time in the video and not do that. The main thing I want you to learn today, of course, is how to multiply complex numbers that are in trig form. And it's really not that hard. You multiply the outside numbers and you add the angles. Okay? Now, let's look at one more topic. And again, my philosophy is to go fast. That way, if you have questions, that way if you're doing fine, you can keep right on going. And if you're struggling, you can back it up and play it again and back it up and write things down. Now, we already know how to divide complex numbers that are in standard form. Let me show you how to divide numbers that are in trig form. And by the way, don't take notes on this unless you want to, but last year we learned if I had 2 plus 5i over 6 minus 3i, something like that, in order to divide those complex numbers in standard form, you would change this middle sign here to whatever it is, you change the sign. And so I would multiply the top and the bottom by 6 plus 3i. It's a really long process. And then you'd have to multiply this 2 all the way through, and this 5i all the way through, and then this 6 all the way through, this negative 3i all the way through, and do a bunch of simplifying. It took quite a while, okay? And so now what we're going to learn to do is the exact same process, multiplying complex or dividing complex numbers, only now we're going to use them when they're in trig form. And believe me, it's a lot easier and a lot faster, okay? So go ahead and copy this problem down, and let's divide these two complex numbers that are in standard form, or in trig form, excuse me. And it's really easy. It's so easy, guys. Watch. You take the outside numbers here and you divide them. You just divide them. So 2 divided by 4 would give you 0.5. Now don't type in 4 divided by 2. It's top divided by the bottom. So 2 divided by 4. There we go. And then you subtract your angles. Now you take the top number first minus the bottom number. You have to do it that way. So 270 minus 90 would be 180 degrees. Plus I sine 270 minus 90 is 180 degrees. You're done. Now to me, that's a million times faster than what we did. Oh, I already erased it. Let me see if I still have it somewhere. I guess I don't. Okay, that's fine. But that, to me, that's a million times faster than what we did in Algebra 2, where we had to, where I had that problem written up here earlier, where you're doing all that multiplication and simplifying. Okay, so when these numbers are written in trig form, it's a lot easier to divide. And you say, what if I wanted that in standard form? No big deal. Just simply, very quickly, this is so easy. If you wanted this in standard form, you learned this yesterday. Just take the cosine of 180, and the cosine of 180 is -1, and then take the sine of 180, and you would get 0. So there we go. Now multiply your 0.5 through. 0.5 times -1 is -0.5, and 0.5 times 0 is 0i. There, you did it. Now you went from trig form to standard form. I mean, guys, I just took the cosine of 180, the sine of 180, and then multiplied my 0.5 through, and that's it. Let's look at one more and we're done for the day. Now here, yes, I've given you some of these in trig form, and I wanted you to quickly, or in standard form, sorry, and I want you to write them in trig form and then divide. Now let's save us a little bit of time here. Let's go back. Did we not already have one that was 1 plus I right here? We did, didn't we? Remember, we already had one that was 1 plus I, if you'll look in your notes at a previous problem, and we had to change that over to trig form. So we've already done that one. So 1 plus I is going to be, what did we get for that? We got square root of 2, and then it was, let's see, it was cosine of 45 degrees plus I sine 45 degrees. So there we go. That saves a little bit of time. So remember, we already had a number like this earlier in our notes, and so I just took that and I wrote it in trig form. Now let's take 1 minus I, and let's write that in trig form very quickly. So 1 minus I is over 1 and down 1. So here's my triangle. Over +1, down 1. And then if you find the hypotenuse, it would be square root of 2. And then if you found your angle here, tangent of x equals opposite over adjacent, you will get 45 degrees, but we're not going to put 45 degrees. We're going to start here and go all the way around. It's 315 degrees, okay? So it looks like to me, this bottom number right here, written in standard form, when we write it in trig form, it's going to be square root of 2, parentheses, and then cosine of 315 degrees plus I sine 315 degrees. All right, so there we go. And now let's go ahead and do our division, and we're finished. When you're dividing two complex numbers written in trig form, you divide these numbers here. So square root of 2 divided by square root of 2 would give you 1. So I'm going to put a 1 right here, and then put your parentheses, and then you subtract the angles. Now you'll get a negative angle. That's okay, no big deal. We can have negative angles as long as they don't get bigger than -360. I'm okay with that. So 45 minus 315, what would that be, guys? Help me out here. I think that'd be 270. So we'd get a -270 plus I sine, and then we subtract 45 minus 315. So we're taking top number minus the bottom number. Always the top number minus the bottom number, and that's why we're getting a negative number here. And let's see, 45 minus 315 would be 270 again, -270 degrees. And there we go. You did it. So now if this angle, pretend for a second this angle was like -425. Well, that's bigger than 360. So what I'd want you to do is go negative around 360. And then what would that be? 25 degrees more. No, 65 degrees more. And so you would use -65 degrees instead of -425. So I always want these angles to be between 0 and 360, or between 0 and -360. We don't want these angles bigger than 360 or less than -360. Okay? So I hope this makes sense. If not, watch it again, back it up, and go over this. Plus, you have a chance to practice on your homework. Now, I've only given you 6 problems. Okay, now I'm not trying to win the Favorite Teacher of the Year award, but I just feel like 6 is enough, and they're going to take you a little bit of time. And so make sure you have these done. Okay, call or email if you have any questions. Hope you guys have a good day today.